Thank you. Thank you. So, a little bit about Southern Company, my employer. Southern Company is one of the largest energy companies in the United States. It has over 9 million customers across 19 different states. We have 11 regulated utilities. We're going to talk about Georgia Power as one of our electric utilities. And it's comprised of electric, natural gas, and other companies, including a telecom company. We have 37,000 employees. I'm one of them, and I'm out of Atlanta. You probably guessed that. So today I'm here to talk about how we're using Azure and Stream Analytics for asset, vehicle, and crew location tracking. An example of an asset is bucket backhoes, trailers, containers, portable substations, and vehicles that we track, mostly bucket trucks, as you would associate with electric companies, as well as line trucks and other fleet vehicles. We also tag those vehicles and equipment with crews, both internally and externally, as is the case when other external utilities come to assist us in power restoration after a storm, like Hurricane Irma last year. So the main focus of my talk today will be to talk about how we use location tracking for these various entities to restore power. But there's other use cases as well. We also use this data in other ways, and we'll see later how we do that, to recover items that are stolen, to promote safe driving, and to protect our workers who may be in remote locations. So the point of this Azure Streaming Analytics use case is really to talk about how we as Southern Company have used the cloud and streaming analytics to obtain business value quickly. So I'm going to talk a little bit about the solution architecture. The solution architecture is a cloud-based architecture. This is a subset. On the right side, you see all the services that comprise the solution. There's two basic inputs, the basic device and the advanced device. The basic device is your simple tracker that will communicate over UDP or TCP protocols. Those basic devices communicate into a collection of cloud services grouped into listener services, parser services, and vendor forwarding services. Most time, basic devices are provisioned by vendors. So when that telemetry comes in from the basic devices, a listener picks it up, places it on an event hub, and then a vendor forwarding service parses that information, publishes it to the IoT hub, and sends it on to the IoT vendor. The point of this solution was really to support multiple vendors and multiple devices and carriers. And what we built is a framework so that each business unit could create their own use case as we described above. So advanced devices are actually iPhones or rugged laptops that sit in the truck. They can communicate directly to the IoT hub. All of this data from both basic and advanced devices flow in. The cloud services that parse the basic devices canonicalize the message, drop it into the IoT hub. Advanced devices publish directly authenticated messages to the IoT hub, and then begins our Azure Streaming Analytics. What I show is the sample we'll look at today is location tracking, where a streaming analytics job picks up these messages, reduces the set so that on-premise systems can absorb this type of data, and then publishes it to Event Hub, where it's brought back on-premise into our outage management system. Other use cases could continue. For example, preventive maintenance, looking for alerts from the vehicle that the oil needs changing, or safe driving, looking at the deceleration patterns of the driver. So we'll show you a little bit of the code. Let's see, 8. So in this example, I'm showing a solution that I built called Tracker, and you'll be able to download this. It's completely run locally, and what I've done is I've put some sample tracker messages from 2 different types of trackers. So the first tracker, the actual basic, these are both basic trackers. The message that comes in is in the body. That's the raw message. And then the parsers canonicalize that message and drop it into this JSON for the IoT. The vendor forwarder will get the raw message as it's received in the format that the vendor requires. And we're using enrichment to publish additional information into this message. For example, what is the device type? What kind of message is this? Is it a location, an alert? Is it a diagnostic? And so forth. So this is one of the examples. And here's another example of an encoded message that's coming from a different type of tracker. We support multiple types of trackers, and those are provided by different vendors. So we can host this framework for different vendors at the same time. And so what I've put together is a sample for a single device over a 24-hour period for different message types. And the purpose of this is to run through this streaming analytics job using a lot of the functions, geospatial functions and analytical functions, along with windowing functions, to reduce this to a manageable set so that our on-premise systems can consume these. In this particular example, this outage location tracking data is flowing into our outage management system. And so the job itself looks like this. And I'll step through it briefly. So the first thing we do is we retrieve the message from the streaming analytics in the IoT hub, and we look at the previous message that we heard from up to 4 hours ago. We filter out any messages without a valid GPS, and then we calculate the distance between the previous message and the current message. We do this because often GPS trackers bop around. The next thing we do is we determine whether this tracker that's sending the telemetry, is this an active tracker or an inactive tracker? If the business results are that if it's an active tracker, we'd like to see the data every 2 minutes. Inactive trackers, every 2 hours is fine. This is a vehicle and not an asset, although I will tell you that a lot of the data that actually comes into the system is more about the assets as well. So in this example, we're defining a parked device as one that has not moved more than 400 meters or a quarter of a mile in 2 hours. And it recognizes a 0 speed. And you say, well, why did you do it this way? Why didn't you just accept the speed and the movement from the actual device? The purpose of this was to support external crews where they may use an iPhone application or an application that pings its GPS. And then we can calculate it whether it's moving or not. So basically, any device that can communicate its lat, long, or geo coordinates, we can actually use in this system. The simplest device to the most advanced. And so once we determine whether it's active or inactive based on those two conditions, we're using a tumbling window, as you see here. Then we collate the two sets together as parked and moving, and we grab the original information from the message that came into the streaming analytics. And then we insert it into the event hub. So if you go back to that first diagram, we move the data from streaming analytics into an event hub. And as subsequent use cases come along, like theft prevention, for instance, if a container door opens and it fires an alert and we know it's after hours, then we will have a new Azure Streaming Analytics solution looking at particular device types as well as an output sync. So I put this together so that you could actually see it and play with it, and certainly if you improve on it, let me know. So you can run the entire job locally, and what it's going to produce is a spreadsheet similar to this, a CSV similar to this. And you can see at the bottom what's highlighted in blue. Most of the tracker information that came in, there were 288 messages, and it reduced it down by 80% into 55 messages. And the key here is that that's a manageable set of data that we can bring into our on-premise systems. So you'll notice the ones in gray are actually when that vehicle was parked and there was no activity going on overnight. This helps considerably to bring the information in. The vendor forwarding for this particular device, the vendor actually gets every single message that comes in. So we actually play a man in the middle where we are brokering these messages to our outside systems and partners who are helping us with either lone worker safety or our telemetry vehicle tracking. Okay, so it's very important that no matter what kind of system you build, anytime you build an IoT system, that you have a dashboard with metrics and alerts. We built this dashboard. This represents a very blue sky day. We didn't have a lot of work going on. In the event of a storm, like in Hurricane Irma, you would quadruple this data, or even more. So as we thought about the solution, we built the solution fairly quickly, and we iterated over the design of the solution in small steps so that the business could see value right away. Instead of going with a vendor-based system and having to go back to them to export this data, we wanted to get a copy of this data. It's our data, and we wanted to analyze it. So that's why we built this system. And as we look towards how we would improve this system, we're doing it in 4 key areas. Let's see. So the first area is the basic device today communicates to cloud services. We want to remove that and take the listener and move that into containers. And we want to move the vendor forwarding and the parsing into functions. They still use the event hub for a pipeline processing. And if I can give you any advice, it would be, as you build these solutions, build them in small, manageable components so that you can replace key components as better technologies come along. The other areas we're improving in is CosmoDB. We're looking at potentially storing for cold path analytics the data that comes in from the IoT hub, which also includes the raw message. And then at the bottom, you'll notice that we're looking at creating an edge gateway with IoT Edge, communicating back and forth with beacons. So why did Southern Company choose Azure and Stream Analytics? Again, the basic idea was we wanted to build a framework so that we could control the data. And as we came up with new business cases, we could build those business cases by our product groups, and they could implement them without IT support. So it's very easy. From a scalability perspective, this system was built to handle storm conditions in the cloud. If we had built this system on premise, as you know, we would have had to scale up and build that system to handle the max situation, which was not very feasible. As it stood, when we put this solution into the cloud, it was very quickly, we were able to scale 3 components to handle Hurricane Irma and watch the trucks moving around. And the actual outage management system that received the data was easily able to handle that amount of data because we weren't giving them 15-second data for every single device out there. Today, there's 1,400 devices with 3,000 more coming online soon. So from a scalability perspective, we found app insights, dashboarding, and alerting to be critical, and it helped us. From a developer productivity, it's SQL. We all know SQL as developers, and the business knows SQL, and they can easily create output sinks in SQL that manages their use case. It's quick to integrate data. In fact, we enrich data coming into the Stream Analytics job, and we can add more data sinks. And it's fail fast, so we can quickly prototype the system and try it out, and the business can as well. And finally, it was an extensible framework. Like I said, we componentized the pieces so that each one could be replaced and updated as necessary. It's easy to update the system, and additional use cases are quick to add. Thank you.